Hello students, in this session we will discuss stack data structure. A stack is a linear data structure in which elements can be inserted or deleted only at one end called top end of the list. Now observe the diagrammatic representation of a stack. So here one end is closed end and the other end is open end. Now this open end allows insertion and deletion operations. Hence this end is treated as top end of the list. Now such a representation is known as stack data structure. So here the basic key point, stack data structure allowed insertions and deletions at only one end, and the end is treated as top end. Now these are stack examples: a stack of trays, a stack of plates arrangement, letter basket, etc. Now these are images. Okay. Now a stack is also known as LIFO list, last in first out list. For this, now observe this one. Assume there are 4 elements 10, 20, 30, 40. Now these elements are inserted into the stack. Now the insertion order is 10, 20, 30, 40. So stack allowed insertions at only one end. So after inserting these elements, the topmost element is 40. Now when the same elements are deleted from the stack, here the first deleted element is 40, since which is the topmost element, then 30, 20, 10. Here the last inserting element is the first deleting element. Hence, a stack is also known as LIFO list, last in first out list. So in stack data structure, the order of deleted elements is reverse order in which they were entered into the stack. Hence, stack is also referred as LIFO list. Now we go for the representations of a stack. So in memory, a stack can be represented in two ways, like static representation, also referred as array representation, and dynamic representation, also referred as linked representation. First one, array representation. So the static representation of a stack uses array concept. So initially assume S is an array used to represent a stack with a maximum size as n. Initially elements are not available in the stack. Hence at this stage the variable top is set at -1 position of the array. Let's example. Assume n equivalent to 4. That means size of the stack is 4. Let us consider two elements 10 and 20. Now when these elements are inserted into the stack, then the status becomes, now in this format, 10 is inserted, 20 is inserted. Now 20 is the topmost element of the stack. Hence the variable top points to 20, where the element is available in the index position 1. Second one, linked representation, is also referred as dynamic representation. Dynamic representation of a stack uses linked list concept. In linked list, different types of lists are available. Here, single linked list is enough to define linked representation. So in this format, elements are represented as nodes in which every node is divided into two parts like data part and link part. Here, data part stores information part of the element and link part stores address of the next element. Now based on this format, now observe this example. This one, the dynamic representation of a stack. Here, it consists 4 nodes and the data parts are 59, 38, 64 and 26. Link parts are filled with address of the next node. Here, for the last node, next node is not available, hence link part of the last node is filled with null pointer. So here list starts at start node and terminates at top node. So these are representations of a stack. Now observe abstract data type for stack. So here in abstract data type, the instances are linear collection of 0 or more elements and operations are push, pop, pick, empty, fill and display operations. Now, operations on stacks. So basic operations on a stack are push, pop, pick, empty, fill and display operations. The first one, push operation. So to implement these operations, initially we consider array representation. So assume S is an array used to perform stack operations with a maximum size as n. Initially elements are not available, hence at this stage the variable top is set at -1 position of S. First operation, push. The process of inserting an element into the stack is known as push operation. So insertion operation means push operation. So in stack concept, to implement push operation, first the variable top is incremented by 1 and then new element is inserted at top position of the stack. While performing push operation, if empty locations are not available for further insertion, then the status of the stack is referred as stack overflow or stack fill. Now remember, so to implement push operation, first we check whether the stack is overflow or not. If stack is not overflow, then apply push operation. Now algorithm format. So algorithm push of x. So this procedure inserts a new element x at top position of the stack. So here first we check whether the stack is overflow or not. For this, if top equivalent to n-1, then print a message as stack overflow. Return from the function and if. If this condition is false, that means empty locations are available. Then step 2, top equivalent to top plus 1. Step 3, s of top is filled with x. Now return from the function. This one, pop operation. The process of deleting an element from the stack is known as pop operation. So deletion operation refers to pop operation. At every pop operation, first delete element from top position of the stack and then the variable top is decremented by 1. While performing pop operation, if elements are not available for further deletion, then the status of the stack is referred as stack underflow or stack empty. That means to implement pop operation, first we check whether the stack is underflow or not. Algorithm point of view. Now algorithm pop. So function is used to delete the topmost element from the stack. So first we check whether the stack is underflow or not. So underflow checking. If top equivalent to -1, then print a message as stack underflow. Return -1 end if. If this condition is false, now k equivalent to s of top. Now top is decremented by 1, like top equivalent to top -1, then return k. This one, pick operation. So the process of printing the topmost element of the stack is known as pick operation. Algorithm pick. Here function returns the topmost element from the stack if exists, otherwise it returns -1. Implementation. If top equivalent to -1, that means elements are not available. Now return -1. Yes, elements are available. Now return s of top. And if. Next operation, empty operation. So empty operation is used to check whether the stack is empty or not. Algorithm empty. Function returns 1 if the stack is empty, otherwise it returns 0. Process of checking. If top equivalent to -1, then that means stack is empty. Return 1. Yes. Return 0. And if. Next operation, full operation. Full operation is used to check whether the stack is full or not. Algorithm full. Function returns 1 if the stack is full, otherwise it returns 0. Checking. If top equivalent to n-1, then that means stack is full with elements. Return 1. Yes. Return 0. And if. Next operation, display. Display operation is used to print elements of the stack. Algorithm display. Here function prints elements of the stack. First we check whether elements are available or not. For this, if top equivalent to -1, then that means elements are not available. Hence, simply print a message as stack empty. Yes, if elements are available. Here elements are available from index 0 to top. Hence, repeat for I equivalent to 0 to top. Do steps by 1. Now we print s of I values. And repeat. And if. Now return from the function. So these are basic operations that can be applied on stack data structure. Now finally, thank you one and all.